Hello, Peter Carter here with a climate emergency video. This video is the data of the spring of 2019, the first quarter of this year, and it covers global surface warming and atmospheric carbon dioxide concentration increase, which in both cases show both are extremely rapid. I'm making the video in June of 2019. The other website that I manage on which you can get this information and more with references, etc., is stateofourclimate.com. This video is also going to be based on and reinforce the imperative of the 2020 emissions deadline. So 2020 is an absolute deadline, a real deadline for global emissions to go into rapid decline, carbon dioxide emissions particularly, of course. We need to be doing that for the sake of the children, all children in the world today, and all future generations. We start with global surface warming. This is data in map form from NASA GISS. And this, now we have the global warming for the spring season of this year 2019, that being March, April, and May. This is from pre-industrial. The baseline is 1881 to 1920, and the global warming for the spring is 1.29 degrees C. I now have to point out that this year's spring 2019, even though 1.29 is a very large degree of global warming, it's not the record in 1 year. The record in 1 year is still the spring of 2016 with the very strong El Nino boosting the global surface temperature an extra bit, and that was a 1 year temperature increase of 1.43 degrees C. Having acknowledged that the big El Nino year 2016 holds the record of global warming in 1 year for springtime, what we really want to know, what we really need to know, is what is the trend? Where are we headed with regards to global warming on a trend basis? And that's where this NASA GISS temperature plotter comes in, and it gives us a graph according to the input that we put on the interactive site. And this is the land ocean, that's the global average surface warming for March, April, May, and this applies a 5-year lowest smoothing. A lowest smoothing is a statistical method which gives us just what we want. It gives us the indication of where we are headed. So just with a 5-year smoothing, 2016 smooths out so that the spring of 2019 represents a sustained rapid increase. With the spring of 2019, the highest warming on just a 5-year trend. So you can see that this is 1.29 degrees C, temperature anomaly, temperature change. Here's the input into the interactive site. And also, if you look back over the entire record since pre-industrial 1880, this rapid long period of steady increase from 2010 is the longest, fastest increase since records began. So this clearly tells us that we are on a rapid heading for global warming planetary catastrophe, proving that we have no more time. We have absolutely no more time. Emissions have to be put into rapid decline on an immediate basis, and that means from 2020. Now back to the NASA temperature maps. NASA gives us two views. This is very, very important. This is the Arctic polar view, and of course this is the map. And we can also get the land warming alone without the ocean, and the land has warmed on average 1.65 degrees C. We can look back over the past few years. Last year, the warming, global warming for spring in 2018 was 1.12. So it's gone up a great deal in 1 year. 2017, it was 1.24 degrees C for the same period. And in 2016 was the big record global warming year, and the warming was 1.43 degrees C. This was due to this very strong El Nino. The El Nino is a phenomenon of the ocean surface warming affecting the Pacific, and that has a significant effect on the entire global climate. We tend to get more surface warming on average, and there tends to be a higher atmospheric CO2 concentration during big El Ninos. The El Nino would show up here, and in actual fact we're in a weak El Nino for 2019 for the present. Back to the whole world. So right away we see that the northern hemisphere, of course, is warming a lot faster than the southern hemisphere having a lot more ocean. But there's some real bad things happening in the northern hemisphere. First of all, the Arctic is warming very, very, very fast. This is Alaska here in the dark brown, and this is Siberia here in the dark brown. So that's the maximum amount of global warming, and that is 4 degrees C up to 7.4 degrees C. So that is an extreme amount of warming, particularly for the springtime. Now there are two regions where instead of warming we see cooling. We see blue, shades of blue. And this is the United States, and this is the spring of this year, and this big region of the U.S. has been unusually cold, and that's a manifestation of climate disruption. We get abnormal cold as well as abnormal heat and seasonal variations. This big region here, it is an effect of the melting of the Arctic. This is cold, fresh water. It's a vast region, and this comes from the vast amount of melting of the Greenland ice sheet and Greenland glaciers. This is extremely important because this potentially disturbs major ocean currents in the northern hemisphere. Now we're turning to the Arctic. The Arctic is very important because of all the permafrost, methane, carbon dioxide feedback, trigger to runaway global heating and climate chaos. So here's a North Pole. It doesn't show the Arctic sea ice. This is Siberia here. There's Asia. China's down here. There's Siberia. There's Europe there. Norway, Sweden, Scandinavia there. Greenland here. Alaska there. And North America here, the United States. And this is a permafrost map. This is year-round frozen ground. This is Siberia. Siberia is vast. And this is Alaska. And here's northern Canada and Labrador there. This is the current spring warming that we're looking at. It's 2019. And for comparison below, here is the same record for the spring of 2016, the record year. And the darkest brown regions are 4 up to 7.4 degrees C of warming. And the white circles I put in, they roughly represent the Arctic carbon, which is in millions of square miles. The Arctic is most important because it holds enormous sources of amplifying feedback to global warming, whereby global warming causes more warming. You'll see that the dark brown regions in 2019 affect the vast majority of the permafrost in Siberia. It includes all the permafrost in Alaska and a very large proportion of the permafrost in Canada. So in the springtime, which of course is especially important with respect to warming and thawing permafrost, this is one of the big reasons for us to be looking at the spring. Almost all the permafrost is being affected by the highest degree of surface warming. If we go back to 2016, it's interesting because although the permafrost regions again are warming the greatest, higher than anywhere else, there's somewhat less. of the permafrost regions being affected than this spring in 2019. So the trend that we are on with respect to the most rapid warming affecting the most crucial regions of high carbon containing permafrost. The permafrost contains double all the carbon in the atmosphere. This is a trend, this is a heading for planetary catastrophe. So we're now turning to atmospheric carbon dioxide concentration, that being the main cause, the main driver of global heating, because most of the heat, of course, goes to the oceans, and the main driver of the global heating, global surface warming. This record is from Scripps Institute of Oceanography, the Mauna Loa Observatory at Hawaii. Scripps started doing the atmospheric carbon dioxide concentration monitoring in 1958. So the Mauna Loa Observatory records, that's the standard for atmospheric CO2. This record is the seasonally adjusted mean or average carbon dioxide concentration. I've taken this inset out here from 2013 up to 2019. And I want to point out this big increase, this sudden spike or upturn in the rate of increase of atmospheric CO2, and you can see it very clearly here as well. There's another one here, which is 2015-2016. This is 2019. This one represents, as I just said, the big El Nino, 2015-2016. Now the same thing is happening this year in 2019, only we're in a weak El Nino, and only the increase is actually bigger. You may have noticed that CO2 is running at 411.26 parts per million. That in actual fact is the recording taken in May last month of 2019. This comes from NOAA. I get the numbers from NOAA. You may also have noticed in this inset that for the June CO2 graph, the concentration is close to 412 parts per million. And this reflects the extremely rapid rate of atmospheric CO2 concentration right now during 2019. This is atmospheric carbon dioxide concentration from the Scripps Institute from 1720 up to June of 2019. Clearly, this shows the explosive atmospheric carbon dioxide concentration increase. And today it's 411.26 parts per million on the seasonally adjusted mean. Here I put the record from 1720 up to the present June 2019 with the much more focus in time record also from Scripps of 2013, and I put down here the monthly CO2, atmospheric CO2 rate of growth. May 2019 is the all-time record, a huge increase of 3.42 parts per million. The previous record on that was 2016, 3.37 parts per million. Going back to 2019, April was 3.08, March was 2.8, February was 3.32, January was 2.87, so that's an average for those 5 months for just over 3 parts per million. I'm sure that this extreme, unprecedented ever rate of atmospheric monthly CO2 growth will reduce. It'll fall back to some extent. However, this clearly shows that we are now into a new phase, certainly since 2013, of greatly increased sensitivity of the climate system. This then is the accelerating trend, constantly accelerating trend in atmospheric CO2 increase right up to the present year and the present month. And obviously that is a trend, a heading for planetary catastrophe. And obviously it means we have no more time. Emissions of CO2 global emissions of CO2 have to decline immediately. This is another record from Scripps. This is atmospheric CO2 concentration over the past 10,000 years. Explosive CO2 increase, very obvious. This is 10,000 years ago here. This is today at 2019, and so you can see how atmospheric carbon dioxide concentration just shoots straight up following the start of fossil-fueled industrialization. So here I'm going to show you how to get the data on atmospheric greenhouse gas concentrations from the NOAA. That's the United States National Ocean and Atmospheric Administration. That's the NOAA there, and you go to the Global Monitoring Division, and that will open up first with the Mauna Loa, Hawaii site. But if you go to Data and Products, you'll see trends in CO2, and you'll see trends in methane there as well. So we go to trends in CO2. First of all, we'll get these two graphs. This actually is a new and really good presentation by NOAA. This is the monthly average Mauna Loa carbon dioxide concentration, and this graph here is the monthly mean CO2, which NOAA has been putting up for a long time, and it just runs from 2015 up to May of 2019, the update being June, presently 2019. Next to it is the complete Mauna Loa record from 1958 up to May of 2019. So you'll see that May of 2019 was 414.66 parts per million. So that is the monthly, and it's a monthly highish average. Here's that seasonally adjusted mean. So the monthly in May was 414.66, and then NOAA gives us, for comparison, the same month a year ago, May of 2018, and that's 411.24. That means a record increase in what the NOAA calls the growth rate of 3.4 parts per million. That's the highest record monthly growth rate. If we click on the growth rate, we get this annual mean growth rate of CO2, and the last full decade is this one of 2000 to 2010. That's a growth rate of about 2 parts per million. Presently in 2019, we're at actually an average of 3 parts per million. Go back another decade to 1990 to 2000, the growth rate is about 1.5 ppm. If we scroll further down, we get a list, a record of the annual atmospheric CO2 growth rate, and we'll get the latest one, which was 2018, which was 2.86, and that is a huge annual growth rate, because just in the decade of the 90s it was only 1.5. The previous record was 2016 at 3 parts per million, and 2015 was almost the same at 2.99 parts per million, and that is the big strong El Nino. If you click on the interactive plots, here's where I get the numbers. Here's atmospheric carbon dioxide concentration, the same record from 1958 up to the present time, up to May of 2019. The blue line is the seasonally adjusted mean, which here NOAA calls the trend, and the sawtoothed up and down with the seasons is the monthly carbon dioxide concentration. If we click on there, the monthly there is 414.66. If we click on to the most recent seasonally adjusted mean, we are at 411.26 parts per million. You can take another subset of this graph by using the slider. We're back to where the NOAA page on greenhouse gas monitoring opens, And all of these are various monitoring stations around the world which you can access from this NOAA Interactive. It's really quite amazing. Zone in on where you want to go. We'll start with Mauna Loa, Hawaii, which is right there. Mauna Loa, Hawaii, carbon cycle gases, time series, and first we get carbon dioxide. So we click on submit, and we get this readout of atmospheric CO2 from 1970 right up to the present time. The latest update is there, and it is the 20th of June 2019. To get a better look at what's happening to the seasonally adjusted mean, we take a subset. Let's change the start time to 2000. So here's atmospheric CO2 from 2000 up to June. This is right up to date, what we're looking at now, to the 20th of June 2019. Here's the up and down sawtooth, seasonally, monthly up and downs. And here is the gray line, which is the seasonally adjusted mean, which NOAA is providing for us again. For a long time they weren't giving us this. And here is 2019. So here's the big rate of increase that we're into right now. This is the past 10 years. I put the start year at 2009 here. With a 10-year period, you can make out the gray line of the seasonally adjusted mean a lot easier. And then you can see that right now, on the 20th of June, the atmospheric CO2 concentration is right up here, and it's increasing extremely rapidly. To wrap up this video, we've discovered a dire emergency situation. We've looked at global average surface warming from NASA GISS from the plotted graph with just a 5-year smoothing and the NASA GISS map. And this shows that the springtime, March, April, May of this year 2019, warming has reached 1.29 degrees C. That's not the absolute record, which is still held by 2016, but global average surface warming is clearly accelerating, and over the past 10 years it has been at a constant rapid increase, and this is the longest, fastest rate of global surface warming increase. What can we say? We see an extremely rapid short-term acceleration. One thing from this and the distribution with the northern hemisphere and the permafrost is that this is a trend, a heading to planetary catastrophe. We have absolutely no more time. We've looked at atmospheric carbon dioxide concentration, and it's very obvious from 1720 up to the present time that atmospheric carbon dioxide is accelerating, it's increasing explosively. And the period from 1720 is a blink in the eye with respect to the timeline of the climate system. We are now already at 411.26 parts per million, and that compares with 300 ppm for the 800,000 year ice core limit. In this year so far, 2019, atmospheric CO2 is increasing faster than it ever has. So that is a certain heading for planetary catastrophe. We have absolutely no more time at all.